In this video, we are going to look at Unit 8, Lesson 1, which is titled Up to Chance. So we are going to start exploring chance. By the end of this video lesson, you will be able to match an experiment with its most likely probability. On page 254, you will see these 4 spinners. Which one does not belong? So take a look at those, decide, write down your explanation, and then come back to the video. All right, so certainly various ideas you could use here of why you decided that one doesn't belong. Maybe you looked at A and you said it was the only one split into equal parts or equal outcomes. B, maybe you said it's the only one with 3 possible outcomes instead of 4. C, you could have maybe said that there's one space here that's more likely than all the other 3 combined. And D has 2 outcomes that are equally likely, one that's less than those and one that's more than those. So maybe that's a reason why you chose D. On page 254 and 255, we're going to take a look at a couple of quizzes that Elena is taking in her Spanish class. So go ahead and read about those 3 quizzes and then come back to the video and we will take a look at some of the big ideas in them and then answer some questions. All right, so for this first quiz for Elena, we've got that she takes time to study, okay, and she understands the material really well. The quiz that she's taking has 20 questions, okay, that are multiple choice, and the answers that she can choose from are A, B, C, or D. She tries her best to answer the questions correctly. In the second quiz, okay, Elena was absent from school a lot and she does not understand the material at all. The quiz still involves 20 multiple choice questions. The possible answers are A, B, C, or D. And she fills in the answer sheet without even looking. Okay, so she doesn't even look at the questions. She just picks random answers. For the third quiz, Elena is still lost in the class and has not come in for any help. The quiz involves 20 questions again. This time they are true and false. And again, Elena answers without even looking at the questions. So let's go ahead and answer some questions about these. I've recapped the quizzes on the top of the screen for you. In quiz 1, she studied. It had 20 questions. Okay, each question had A, B, C, or D as a choice. Question 2, or quiz 2, she didn't look. She just guessed without looking, 20 questions, multiple choice. Quiz 3, she again guessed without looking, 20 questions, and this time true or false. So answer the questions on page 255, and then come back to the video. All right, so if we were going to rank these quizzes in order of worst to best expected grade, how do we think that that would play out? So likely here, she studied in quiz number 1. So we do think that quiz number 1 should be the best grade. Okay, so if she studied for it, she knew what she was doing. Quiz number 1 should be the best grade. What one do we think would be the worst grade? So she didn't look at either of these. They each had 20 questions. Okay, this one had more possible answers. So it's probably likely that quiz number 2 was her worst grade and quiz number 3 was maybe in the middle. How much do you think chance played a role in each of these grades? So chance just in quiz number 1, not very much because she studied, she understood what was going on, she was making educated guesses, so not much. But quiz 2 and 3, she was just guessing at random. Okay, so it's probably chance has a large role. Since she's just guessing, circling at random. Okay, so chance is playing a pretty big role in those two. For the second and third quizzes, Elena did not look at the questions. Explain why you think she might do better on one than the other. So why do we think she would do better on quiz 3 than quiz 2? And because in quiz 2, there were more options. Okay, she was choosing from A, B, C, and D, and only one of them was right. So there was one, let's say it was A, correct answer, and then there's 3 wrong answers versus a true false. Okay, 1 is right, 1 is wrong. So there's only 1 wrong answer, 1 right answer versus 3 wrong and 1 right. What percentage of the questions do you think Elena will get right on each quiz? So you could, she studied on the first one, said she knew it pretty well. So for quiz 1, maybe she got like a 90 to 95%, 85, something like that. Okay, quiz 2. Maybe you thought she got like a 25%. Quiz 3, maybe you thought she got a 50%. Okay, because on each question on quiz 2, there were 4 options. 1 of them was correct. Okay, 4 of them were wrong. And 1 out of 4 is a 25% chance versus true and false. 1 right, 1 wrong. So it was likely that she had a 1 in 2 chance of being right. So that's a 50% chance. For the second quiz, the teacher made a mistake. Each question had 2 correct answers. Okay, so remember quiz 2 was 20 multiple choice questions, and the options were A, B, C, and D. And the teacher made a mistake, and 2 of them were correct. And then the teacher accepted either one for full credit. So now A is correct and B is correct versus C and D are wrong. So what do we think about the percentage that she would get correct now? So now there's 2 correct answers, 2 incorrect answers. So maybe this would change it to a 50% instead of a 25%. So Elena got a 90%. So now we're telling you her scores. So her grade on the first quiz was a 90%. And her grade on the third quiz was a 95%. So remember that first quiz. Okay, quiz 1 is where she studied. Okay, and it was the 20 questions, and it was A, B, C, D. And then quiz 3 was where she didn't even look. Okay, so she didn't study. Guessed at random. There were 20 questions, and they were true and false. So this is saying that she ended up with a 95% on this third quiz, and on the first quiz, she had a 90%. So is this impossible? Is it unlikely, or is it expected? Okay, so is this what you expected to happen, that she did better on the third quiz? No, we expected her to get a worse score on that third quiz. So it's not expected. Is it impossible? No. She could have guessed really well on this and just gotten a really good score. She was just a really good guesser, or really likely. So it's not impossible, okay? But it is unlikely. Okay, so it's unlikely that she guessed all like 19 out of 20 questions correct on that, just at random, but not impossible. All right, so here's some vocabulary for as we're talking about probability. So we have outcomes, and outcomes of a chance experiment is one of the things that can happen. Okay, so as you're doing an experiment, it's one of the options. Okay, it's something that can happen. The sample space is the list of every possible outcome. And then an event is what you're focused on in the experiment. So when we're looking at, for instance, rolling a 6-sided number cube, all of the outcomes are things that can happen. Okay, we could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Okay, the sample space is this list of everything. And then an event is what you're focused on. So if we said that we're going to roll an even, okay, that would be the event. And the outcomes are going to be the even numbers, which would be 2, 4, and 6. Those are the outcomes of this event. And the sample space is still 1 through 6, what could happen, versus our event and what the outcomes are of that event. Or if we said, whoops, that we're going to roll a 4. So then the outcomes of this event is, how do we roll a 4? Well, that's by rolling a 4. And the sample space is still 1 through 6. That's the options that could happen when we roll the dice. Okay, the 4 is the outcome from this event that we're focused on. So our event was rolling a 4. Here, our event was rolling an even. Okay, so event, outcomes, sample space. So what event was Elena concerned with? Okay, and the event that Elena was concerned with was getting the correct answer. Okay, selecting the correct answer. So that's the event. Okay, so what outcomes in quiz, now we're looking specifically at quiz number 2. Okay, what outcome of the event, what was the outcome of the event before the teacher realized their mistake in quiz 2? Okay, so there was one outcome, okay, because there was one correct answer. And then what were the outcomes of the event after the mistake was realized? So once the teacher realized there was a mistake, it's because there were actually 2 correct answers or 2 outcomes for that event. So then if we take a look at probability, so probability is what we're going to be looking at in this chapter, and probability is just a way to talk about the likelihood that an event is going to occur. Okay, so the likelihood that the event is going to occur. And probability is always between the number 0, which means that an event can never, ever happen. It is not possible. And 1, which represents 100%, which means the event has to happen. And so you're on a spectrum here between 0 and 100 of those of the likelihood of an event. Can never have more than a 100% chance of an event happening, and can never have less than a 0% chance of an event happening. So in thinking about probability then, on the second quiz, what was the original probability of Elena getting the correct answer? So this was the multiple choice quiz that had A, B, C, and D. So originally, there was one correct answer. Okay, so there was one correct answer out of a possible 4. So 1 correct out of a possible 4, that would be a 25% chance, or a 0.25 probability. So as a decimal, that's 0.25. Thinking about it as percent, 25%. So what did that change to when the teacher realized their mistake? So now we've got these 4 choices. Now 2 of them are correct. So now 2 are correct out of a possibility of 4. So that's going to be a 0.5 probability, or 50% chance. And then what is the sample space for each quiz? So in quiz 1, we had options of A, B, C, and D. So that was the sample space. For quiz 2, each question was multiple choice with answers of A, B, C, or D. So that was the sample space. And quiz 3 was true and false. So the sample space there was just true or false. What if each quiz had 5 choices with 1 correct answer? What is the probability that Elena gets each question correct? So now she has 1 correct answer out of a possible 5. So she's looking at a 0.2 probability, which is a 20% chance. All right, then on page 256, we've got this spinner. Han, Claire, Mai, and Kyron are inventing a game for the county fair. Players are going to spin this spinner, and if it lands on section B, the player is going to win a prize. So they kind of hypothesize some different things that they want to do with this. Han says that he's just going to have them spin once, and if they land on B, that's going to be the winner. Claire says she's going to also have them spin the spinner, and if it lands on B, they're going to win. But if they lose the first time, they're going to get a second spin. So they're going to get to spin again. And then Mai wants to change the spinner to have 3 sections, okay, 3 equal sections. And then if they land on B, they're the winner. And Kieran wants to just change up the sections of the spinner. So he's going to make just 2 sections, but A is going to be this size, and then B is going to be this size. Still, if they land on B, they are the winner. So go ahead and rank the probability from least to greatest that somebody wins. So who's going to have the least chance of winning? Who's going to have the best chance of winning? So you could have different justifications and reasons for this, but it does seem like Kieran's is probably the least likely because of how small that section is. Okay, it appears to be maybe like 1/8 of the circle. So it looks like we could split that into 1/4. So it looks like it's only about 1/8 of the circle. So like a 12% or 12.5% chance. Mai's looks like hers is the largest portion, okay, because it's 1/3. So hers maybe looks like it's the best chance or like up there somewhere. So hers has a 1 in 3 chance. Han was spinning once and it's a 1 in 4 chance. So his is kind of between those two. That's a 25% chance. Okay, versus Mai, if we divide that, would get a 33% chance. And then Claire's starts at a 25% chance, same as Han's, but then if they lose, they get to spin again. Okay, so maybe you're thinking that pushes Claire's method to above Mai's, okay, because they get to spin again. So maybe that's the best chance. Maybe you're not sure. Maybe Claire's is going to go here. Okay, so one of the two. Thinking through the various sizes of the spinner choices there. So here's some actual results, and these are listed on page 257. So here are some actual game results from the people that played these spinners. So let's estimate, let's figure out the estimated probability here, and that's going to involve taking the number of wins, okay, because that's the event that we're looking at, is that the people win. And so we'll do the wins divided by the total number of plays. Okay, so you actually want to add these two together to figure out how many times people played to figure out the number of wins. So 2513 divided by 10,029, and we get about 0.25 or 25%. So go ahead and do that for these next 3. So should have gotten 876 is the wins divided by 2,003 times that people played, which gave us 0.437 or about 44%. For Mize, it was 2,026 divided by, was the number of wins divided by 6,010 total times the game was played. So that gave you 0.337 or about 34%. And then Kieran's was 322 divided by, for the number of wins, divided by 3,943 times that the game was played in total, which gave you a percent, so a decimal 0.081, so about 8% of the time people won. Number 3 on page 257, it says that by talking to their friends, they figure out that a good probability for winning is about 1 in 5. Okay, so then a good chance for the game is if people are winning 1 out of 5 times. That'll make sure that people are winning enough that they're happy, but also that it's not going to cost them too much in prizes. So 1 in 5 would be a 0.2 probability or 20%. So which of these methods is best for that? So out of these, it appears that Han's method is best because it is closest to a 20% chance based on these game results. So before the players decided on a spinner game, they considered other things at their booth. These are the 4 other games that they looked at. Which of these are actually chance experiments, meaning that they are completely up to chance and no skill is involved? So read through those 4 and decide which ones are chance experiments and which ones are not. So we've got a watermelon eating contest. The fastest to eat the wedge of watermelon wins a prize. This is not based on chance. Okay, this will be based on how fast you can eat. 2 cubes have 1 face labeled win. If both cubes land on the win, with the win side facing up, the player wins a prize. So rolling die, completely chance. A ball is placed under 1 of 5 cups. The cups are shuffled around under a cover, so the player cannot see how they are moved. So you can't just watch the cups and determine where it went. The player chooses one of the cups at the end and wins a prize. So this one is completely up to chance since they cannot see what's going on. And the 4th one, players push a button that starts lighting up different regions on the board. The game is rigged so that every 5th person wins. So this is not up to chance because we know it's a pattern, so we know who is going to win. So as they step up, if they're the 5th person, they're going to win. So that is not based on chance. So again, a chance experiment is just something you can do over and over again, and you don't know what will happen each time. So there's no pattern to it. There's no rhyme or reason. It is 100% up to chance. So going back to the results for the games, why did the computer generate 2,513 wins and 7,516 losses for Han's method? So remember that Han's method was just this one where they spun a spinner split into 4 equal spots. So why did they get 2,513 and not exactly 3 times more losses, which would have been 7,539? So why was it not exactly 3 times more losses, which is what we would expect when a spinner is split into 4 equal places and 1 wins? So if 1 wins, 3 loses, or 3 lose. And so because it's up to chance, so every time it resets, okay, you're not guaranteed to have exactly 1 win to 3 losses, but the more and more times you play it, the more and more the probability will be closer to that 25%. So what would a spinner look like if it had a 1 in 5 chance of winning? So it would have 5 equal spaces. So split into 5 equal spaces or sectors. And then why isn't the watermelon eating contest a chance experiment? Okay, because it takes skill. Somebody could, I mean, not necessarily skill, but you know, you could put somebody like a 2-year-old up against an adult and you know who's going to win. Okay, so you know that you know which person is going to win because they can eat faster. And so it's not just completely up to chance. And if you had the same person playing it against a new person, okay, they've probably eaten too much watermelon. So the new person, it's going to be more likely to win. So not up to chance. All right, so I have a coin underneath this box. Go ahead and decide whether you think it's heads or tails. And then we're going to answer some questions about it. So what do you think, heads or tails? So it's tails. And so what is the sample space for flipping a coin? So what were the options here for flipping a coin? And so the options that it could have been here is heads or tails. So that's my sample space. So what was the probability going to be that it showed heads? And so the probability of heads is a 1 out of 2 chance. What's the probability that it would have been tails? So again, that's 1 option is a winner out of 2 total chances. And so that's going to be 0.5 for the probability or 50% chance. So same with this one. All right, so here's your summary for lesson 1. Go ahead and read through it. And then I've underlined a few things that I think are important. Hopefully now you're able to find and estimate probability using a model or data from a chance experiment. And you hopefully know what makes something a chance experiment. Be sure to check your understanding of this lesson with the lesson 1 practice problems. And if you're needing help on those, be sure to look at the video that I have going through the practice problems. And then for this lesson, you can try this cool down. If you are struggling with it, be sure to reach out to your teacher for help.